Welcome to Quantum Mechanics 48th lecture. Problems Part 3 for BSc Semester 5 students. Problems in Quantum Mechanics. And with this, we complete problems from this chapter. Look at the first problem. And you have to carefully study this. Show that the commutator x comma xh commutator is equal to minus h cut square by r. Perhaps you have tried this problem as homework. I told you in the last class about this. The question is x comma xh commutator, whole commutator is minus h cut square by r. So we use the commutator relation. That is a comma b is equal to ab minus ba. Therefore x comma h, you write x in the place of a and h in the place of b. We get xh minus hx. And you remember they will not cancel. It is commutator. Now you again write LHS x h commutator whole commutator, that is equal to x comma xh minus hx. Again apply in a commutator relation. That is x into xh minus x comma xh minus hx inside the bracket commutator. You expand, that is equal to x into xh minus hx minus xh minus hx into x. Remove the bracket. X into x square. That is x square h minus, write in the order, x hx minus second bracket x hx plus minus plus hx square. Is equal to x square h minus 2x hx plus hx square. There are two x hx term in the above expression. So LHS x comma xh commutator whole commutator is equal to x square h minus 2x hx plus hx square. The step repeated. Take the let this commutator be operated on wave function psi. ഈ കമ്മ്യൂട്ടർ വേവ് ഫംഗ്ഷനിൽ ഓപ്പറേറ്റ് ചെയ്യുന്നതായിട്ട് വിചാരിക്കുക. That is x comma xh commutator whole commutator psi is equal to x square h minus 2x hx plus hx square psi. You take a psi inside the bracket is equal to x square h psi minus 2 x psi plus hx square psi. We know the h operator, Hamiltonian operator, HOP is equal to minus h cut square by 2 d square by d square, dou square by dou square plus v. That is the Hamiltonian operator. And you know, for a free particle b is equal to 0. So here in this equation, for simplicity, in this problem, for simplicity, we can use a free particle Hamiltonian. We put v0. Therefore h is equal to minus h cut square by 2 d square by d square. So LHS is x comma xh commutator whole commutator psi is equal to, we write h operator in the above equation, x square into minus h cut square by 2 dou square by dou square psi minus 2x minus h cut into minus h cut square by 2 dou square by dou square xi is put in bracket plus minus h cut square by 2 into d square by d square into x square psi. LHS is repeated as such. RHS is again we rewrite. RHS we rewrite. That is minus h cut square. H cut square by 2 is a constant. We can write in front minus h cut square by 2 s square dou square psi by dou square plus second term minus into minus plus 2x h cut square by 2m dou square by dou square xi last term minus term minus h cut square by 2m dou square by dou square x square psi. Is equal to RHS is equal to minus h cut square by 2m s square dou square psi by dou square plus 2x h cut square by 2m dou by dou x x dou psi by dou x plus I into 1. That is, here you look in the second term of the RHS, we use the product formula. We differentiate it once. Apply the product formula. Differentiate once. That is d by dx of d by dx xi, dou by dou x of dou by dou x xi. We write the product formula, first function into derivative second plus second function into derivative first. That we are doing. That is written here. That is second time in the RHS. 2x h cut square by 2m dou by dou x into x dou psi by dou x plus I into 1. dx by dx is 1. Minus. In the last time also you apply the product rule. One, you differentiate once. Minus h cut square by 2m dou by dou x into s square dou psi by dou x plus I dou x. Again step repeated. And this is like this step you will be here. Minus h cut square by 2m s square dou square by dou square plus, the step is simply we are removing bracket. 2x h cut square by 2m dou by dou x x dou psi by dou x plus 2x h cut square by 2m dou psi by dou x again times. The step continues. Minus h cut square by 2m dou by dou x s square dou psi by dou x minus 2h cut square by 2m dou by dou x of psi x. Because when we remove bracket, we get more terms like this. So there are 1, 2, 3, 4, 5 terms in the RHS. You see how they come. And next step. Therefore, LHS x comma x h commutator whole commutator psi is equal to minus h cut square by 2m x square dou square psi by dou square plus 2x h cut square by 2m. Again we differentiate. Again we take dou by dou x inside. Differentiate. X dou square psi by dou square plus dou psi by dou x into 1. We apply the product formula. Plus 2x h cut square by 2 dou psi by dou x minus, the step continues. Product formula again we apply. Minus h cut square by 2m into s square dou square psi by dou square plus dou psi by dou x into 2x minus, again product formula, minus 2h cut square by 2m into psi into 1 plus x dou psi by dou x. That step contains how many terms you look? 1, 2, 1, 2. There is a term in the bracket also. 3, 4, 5 terms. Again we remove the bracket. Terms increase. Is equal to minus h cut square by 2m square dou square psi by dou square plus 2x h cut square by 2m x dou square psi by dou square plus 2x h cut square by 2m dou psi by dou x. Step continues. Plus 2x h cut square by 2m dou psi by dou x minus h cut square by 2m x square dou square psi by dou square minus h cut square by 2m 2x dou psi by dou x minus 2h cut square by 2m psi minus 2h cut square by 2m x dou psi by dou x. Now the step is you remove the brackets. In the above steps there is bracket. We remove the bracket. when we remove the bracket, we get minus h cut square by 2m. I am reading the third line, that is equal sign. Second equal sign step I am reading. Minus h cut square by 2m, x square dou square psi by dou square plus h cut square by 2m. 2x square dou square psi by dou square plus h cut square by 2m. 2x dou psi by dou x plus h cut square by 2m. 2x dou psi by dou x minus h cut square by 2m. S square dou square psi by dou square minus h cut square by 2m. 2x dou psi by dou x minus 2h cut square by 2m psi minus 2h cut square by 2m x dou psi by dou x. നമ്മൾ അങ്ങോട്ട് സൂക്ഷിച്ച് നോക്കുകയാണെങ്കിൽ കാണാം ടേമുകളൊക്കെ വെട്ടിപ്പോകുന്നത് കാണാം. 2 ടേമേഴ്സ് പോകുന്നത് കാണാനില്ല, ബാക്കിയില്ല. ഏതൊക്കെ 2 ടേം വെട്ടിപ്പോകാത്തത്? The 2 terms remain. They are marked with the 2 lines, underlined. 2 ലൈൻ കൂടി ഞാൻ അല്ലല്ല, അത് ക്യാൻസൽ ചെയ്യുന്ന ടേമാണ്. ക്യാൻസൽ ചെയ്യാതെ അവശേഷിക്കുന്നതാണ് നോക്കിയേ. നമ്മൾ ടേംസ് വെട്ടിയിട്ടുണ്ട്, പിന്നെ 2 ലൈൻ ഞാൻ അണ്ടർലൈൻ ചെയ്ത് കാണിച്ചിട്ടുണ്ട്, അത് ക്യാൻസൽ ചെയ്യും. പിന്നെ ക്യാൻസൽ ചെയ്യാതെ വരുന്നത് ലാസ്റ്റ് ലൈനിൽ ഒരു ടേമുണ്ട്. അതുപോലെ പിന്നെ ക്യാൻസൽ ചെയ്യാത്തത് അടുത്ത സ്റ്റെപ്പ് കൂടി നോക്കാം. അവിടെ ക്യാൻസൽ ചെയ്യാതുള്ള ടൈം നോക്കുക ഏതാണെന്നുള്ളത്. ക്യാൻസൽ ചെയ്യാതുള്ള ടേം ഒരു ടേമാണുള്ളത്. ഈ minus 2h cut square by 2m psi മാത്രമേ ഉള്ളൂ, ബാക്കി എല്ലാം വെട്ടിപ്പോവും. ഇവിടെ ക്യാൻസൽ ചെയ്യാൻ നിൽക്കുന്ന ടേം എന്ന് പറയുന്നത് ലാസ്റ്റ് ടേമിൻ്റെ തൊട്ട് മുന്നിൽ ടേം മാത്രമേ, ബാക്കി എല്ലാം വെട്ടിപ്പോവും. നിങ്ങൾ വളരെ കെയർഫുള്ളായിട്ട് ചെയ്താൽ കാണാം. അപ്പോൾ LHS become equal to RHS, that is minus 2h cut square by 2m psi. ഈ 2 വെട്ടിപ്പോവുമല്ലോ. സോ വി ഗെറ്റ് LHS x comma xh commutator psi is equal to minus h cut square by m psi. This is an eigenvalue equation. Si is Si. Capital Si is small si. So comparing with it, we get the operator x comma xh commutator whole commutator is equal to minus h cut square by m. That's the proof. All steps are written. You read carefully and study. Now, 1 or 2 problems are given which are frequent questions, repeated questions, and very easy to do. Show that A B comma C commutator is equal to A comma C commutator into B plus A comma B C commutator. തെളിയിക്കാനാണ്. അപ്പോൾ LHS RHS തെളിയിക്കുക. ഈ വെക്ടർ പോലെ നമുക്ക് തെളിയിക്കാവുന്നതല്ലേ, വളരെ ഈസിയാണ്. യു ടേക്ക് LHS A B comma C whole commutator, that is ABC minus CAB. Equation number 1. LHS becomes that. And what will happen to RHS? We take RHS. RHS is AC commutator into B plus A into BC commutator. AC commutator is AC minus CA into B plus A into BC minus CB. Remove the bracket. In the order, you write the operators in their respective places. ACB minus CAB plus ABC minus ACB. The 2 terms cancel. ACB term cancel. We get ABC minus CAB. That is the RHS. From 1 and 2, we see that LHS, RHS are same. RHS are same. So we can equate LHS. So from 1 and 2, we get LHS is equal to RHS. That is the proof. Next, prove the commutator relation. Commutator relation CA, B, CA, B commutator, not CA, it is bracket. A, B commutator, C whole commutator plus B, C commutator, A whole commutator plus C, A commutator, B whole commutator equals 0. ഈ എല്ലാ കമ്മ്യൂട്ടേറ്ററും കൂട്ടിയാൽ 0 ആണ് തെളിയിക്കാൻ. You see it once again. Prove the commutator relation A, B commutator, C commutator, C whole commutator, B, C commutator, A whole commutator plus C, A commutator, B whole commutator equal to 0. The proof is very simple. A, B is AB minus BA. Therefore, A, B, C, B write as AB minus BA, C. Remove the bracket. AB minus BA into C minus C into, that is expansion. AB minus BA. Remove the bracket. ABC minus BAC minus CAB plus CBA. Similarly, B, C commutator, A commutator is equal to expand it. We get BCA minus CBA minus ABC plus CB. Again, you apply expand CA commutator, B commutator is equal to CA minus AC, B whole commutator that is equal to CAB minus ACB minus BCA plus BSC. So LHS we can repeat. A, B, C commutator whole commutator, B, C commutator, A whole commutator plus C, A commutator, B whole commutator is equal to, add the terms. Each term contains 4 terms. So altogether there are 12 terms. 12 terms. They will cancel. You look in the order. In the order, there is plus 10 minus 10. They will cancel. We get a 0. So LHS is RHS. Next question. Show that A, BC commutator whole commutator is equal to ABC minus AB minus BCA plus CBA. Prove it. So that we have done in the previous question itself. We have expanded it. Only expansion we have to show. LHS is A, B, BC commutator whole commutator is equal to, that we have expanded A, BC minus CA commutator whole commutator. That is A into BC minus CB minus of BC minus CB into A equal to ABC minus ACB minus BCA plus CBA. That is RHS. And this question is a repetition question, and you have studied in eigenvalue and normalization problem. And this I have given you as a homework, and you have done it. And that homework again repeated again here. It is repeated. If you have any doubt, you look here. It is a repetition question. So because we are concluding the problems, it's a repetition question. Normalize the wave function psi is equal to a sine n by x by 2a. In the limit is written there for x is in between minus a and plus a. The domain is minus a less than or equal to x less than or equal to a. You have to write that step also. Normalize the function, given function, psi is equal to a sine. There is no psi inside. A sine n by x by 2a for a domain as a minus a less than or equal to x less than or equal to a. അതായത് മൈനസ് എ പ്ലസ് ഇൻറ്റഗ്രേറ്റ് ചെയ്തിട്ട് നമ്മൾ പിന്നെ നോർമലൈസ് ചെയ്യാനാണ്. So normalization condition, you know, integral minus a to plus a psi star psi dx is 1. The function is written integral minus a to plus a sine n by x by 2a into a sine n by x by 2a dx is equal to 1. A is the normalization constant. That we write as a into a square sine integral minus a to plus a sine square n by x by 2a dx is 1. That is a square integral minus a to plus a half of. When you integrate the sine square, you have to write as half of 1 minus cos 2a or cos 2 theta. 1 minus cos 2 n by x by 2a dx is equal to 1. And you know, for this limit cos function or sine function like this is 0. So we mark a 0 as shown there. A square into half. Then there is only 1 dx. That is x minus a to plus a is equal to 0. A square into half. A minus a equal to 0. 2 minus are coming. A square into 1 by 2 into 2a is equal to 1. A square into small a is equal to 1. That is a square is equal to a square into small a is 1. A square is 1 by a is 1 by root a. That is the normalization constant. Therefore, normalized wave function is psi is 1 by root a sine n by x by 2a. Next question. If H is a Hamiltonian operator for a free particle, remember free particle, and P the moment operator, prove that commutator HP is equal to 0. H Hamiltonian operator ആണ് ഫ്രീ പാർട്ടിക്കിളിൻ്റെ പി മൊമെൻ്റ് ഓപ്പറേറ്റർ ആണ് എങ്കിൽ H, P commutator 0 ആണെന്ന് തെളിയിക്കാൻ. And you know the expansion H, P equal to HP minus PH. Here it is given a free particle Hamiltonian. You know Hamiltonian operator is minus H cut square by 2m dou square by dou square plus V. For a free particle, you know V is 0. Therefore, Hamiltonian for a free particle is minus H cut square by 2m dou square by dou square. And P is P op minus I H cut dou by dou x. Therefore, H, P commutator psi equal to minus H cut square by 2m dou square by dou square into that is SP minus PH we are writing into minus H cut dou by dou x minus H cut dou by dou x into minus H cut square by 2m dou square by dou square. You can put them in a single bracket. All are into terms except one, the middle term, middle portion, that is minus. Others are multiplied. That is equal to H cut square by 2m, I H cut dou square by dou square by dou x minus I H cut dou by dou x into H cut square by 2m dou square psi by dou square. And we again repeat H cut square by 2m into I H cut once here dou square by dou square of dou psi by dou x. So we can write like this: dou by dou x of dou square by dou square. The second derivative of a first derivative. That we can write as first derivative of a second derivative. That's the meaning. ഒരു ഡെറിവേറ്റീവിന് സെക്കൻഡ് ഡെറിവേറ്റീവ് കാണാനാണ്. അതിന് പകരം സെക്കൻഡ് ഡെറിവേറ്റീവിൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് ഉണ്ടായാലും മതിയല്ലോ. ആ ഡി ക്യൂഡ് ബൈ ഡി എസ് ക്യൂഡ് എന്ന് എഴുതാൻ പറ്റും, അങ്ങനെ എഴുതാൻ പറ്റും. മൈനസ് ഐ എച്ച് കട്ട് സ്ക്വയർ ഡോ ബൈ ഡോ എക്സ് ഓഫ് ഡോ സ്ക്വയർ സൈ ബൈ ഡോ എക്സ് സ്ക്വയർ. രണ്ട് ടൈം ഒരുപോലെ ഇരിക്കണത്, അതുകൊണ്ട് ക്യാൻസൽ ചെയ്ത് പോകും. ഇസിക്വൽ 0. ദാറ്റ് ഈസ് എച്ച് പി സൈ ഇസിക്വൽ 0. എച്ച് ബി കമ്മ്യൂട്ടേറ്റർ സൈ ഇസിക്വൽ 0. സിൻസ് psi is not equal to 0, s comma p is equal to 0. That is the answer. With this, the part 3 problems of your quantum mechanics is over. What now remains in the syllabus is 2 essays from chapter 3. 2 essays from chapter 3 remain that we take in the next classes, and this is the 48th lecture, and I think 2 or 3 lectures are needed to complete the syllabus. That is all. Thank you very much.